In this example, we're going to look at the central limit theorem. So first of all, just to show you what the central limit theorem is, first of all, and what it actually means. So if a random sample of size n with a mean of x is taken from a population with a mean of mu and a standard deviation rho, then the sample size, if the sample size is large, so if it's greater than or equal to 30, the distribution of the sample means will approximate to a normal distribution regardless of what the population distribution is. So the mean of the distribution will be the same as the population mean. The standard deviation of the sampling distribution is given by this here formula. So what that means in this context is we were already given a formula to calculate the z-scores. This here will help us to calculate it now for a sample size of n greater than or equal to 30. So this formula is also referred to as the standard error of the mean. So as n increases, the standard error gets smaller. If the underlying population is normal, the sampling distribution of the mean will always have a normal distribution, even if the sample size is smaller. But that's only if it tells you that it's normal. Sometimes you don't know, but as long as the sample size is big enough, then you're able to continue. Now, this is the new formula for calculating the z-scores. We already had the formula before. You basically take this part out of it. That was the formula before. Now, since the sample size is large and we don't know, it doesn't tell us that it's normal, we can assume that it's normal if we're going to use this part of the formula. So a sample size of 250 is selected from a population of a mean of 30 and a standard deviation of 5. Find the probability that the sample mean is greater than 30.5. So the first thing we need to do is we can write down that it's normally distributed. We can write down the central limit theorem. That's why it's normally distributed. And then we're going to calculate our values from this. So z is equal to this here formula. We can fill our values in. So it's going to be 30.5 minus the mean, which is 30. And it's going to be all over the standard deviation divided by the square root of n. And then what we can do is put the full thing into the calculator and get our answer, which is 1.581. Now, so this is what the z-score is equal to, and then we need to use our log tables then to find out what the probability is. So we're going to, first of all, figure out, it says, find the probability that the sample mean is greater than this here. So we're looking for a value that is greater than 1.581. So we know already 1.581 is in a positive direction. Now we're looking for a value that is greater than that. So to find out what that would be, we need to work out the probability of that z is less than or equal to 1.581, and we need to take that answer away from 1. So we need to do 1 minus that to figure out what the probability above would be equal to. So we need to go to our log tables. We need to go to 1.581. So we need to go to 1.58, which we can see would be over here, and our probability is equal to 0.9429. So it's going to be 1 minus 0.948. Let's say 1.9429. And then we take that away from 1, and it's 0.0571. Okay, so that is the probability that the mean is greater than 30.5. This example, a normal distribution has a mean of 40 and a standard deviation of 4. If 25 items are drawn at random, find the probability that their mean lies between 38 and 40.5. So we have our formula. We're going to first of all use the value that x is equal to 38. We're going to fill our values into the formula. So it's going to be z is equal to x minus the mean all over the standard deviation divided by the square root of n. fill all of the values into the formula. So it's going to be equal to 38 minus 40 all over 4 divided by the square root of 25. First answer is equal to minus 2.5. We're going to do the exact same thing one more time, this time for n equal to 40.5. Fill the values into the formula. So it's going to be 40.5 minus 40 all over 4 divided by the square root of 25. Get our answer for that part in the calculator, which is 0.625. So we know that our values have to be somewhere between those two values. If we draw it out in the diagram, you've got the 0.625 here, and you've got the minus 2.5 on the other side, and we're looking for the area in the middle of all of that. So we need to figure out the area from here back. We need to figure out the area from here back, and then we can take it away from 1 then. So to figure out, first of all, the probability that z is less than or equal to 0.625, we can find that one out straight away, which is equal to 0.7324. Find that in your log tables. And to get the area to the probability that z is less than or equal to minus 2.5, we need to actually find out, first of all, 1 minus the probability that z is less than or equal to 2.5. If we work that answer out, it's 0.00621. And then we need to take these two values away from each other. So it's going to be 0.734 minus the 0.00621, and we will get 0.7262. So the probability that the mean lies between 38 and 40.5 is 0.7262.